Welcome to Coding with Tom. Today we're going to be creating a feed section in our furniture app. This feed will mimic part of the layout that we see in the App Store for iOS 13. We'll be creating different sections, each with a unique layout that will have multiple or single elements per group.
We will also make it possible so that this view is displayed both on iPhone and iPad.
If you have a close look at it, the second section where it says iPhone Starter Kit, we're going to have a grid. For this, using SwiftUI with iOS 13 is not very practical and, to be honest, not worth the effort. So if you have constraints for this, I really recommend embedding a UI view that uses a UI collection view. In our case, we're going to use SwiftUI, but we're going to be using the Xcode 12 beta, and we're going to be using iOS 14, where we can use HGrid and VGrid in SwiftUI. For our banners and new sections, we're going to be having new images. So we're going to have not new models, but new view models. I'm not going to be creating the services to fetch all of these. The stores, we already have it. But for the feature products and banners, we're just going to have the view model created directly with mock data. Now that we have these images, I'm going to be creating the view models for our sections, and then which will be this one, and then the items for each of the cells on each of the sections. This is how I'm going to be creating every section. So the section will conform to a protocol FeedSection. You'll see later on why I'm going to be creating a protocol for this. Each of the sections will have an ID. Remember that in SwiftUI, whenever you're using a for each, the items need to be identifiable. So we're going to use the ID for that. And then we'll have a name, which is optional because some sections, as you can see here, won't have a name and some do. Now this is for the banner. So again, we have an ID, a name, and then items. For each banner item, we're going to have a title, a subtitle, and then the image. Now let's do it for here, which will be our stores. This part that's called kit zones will be advertised products, no, feature products. And then here we will have the options part section. And here we have our view model. So we'll have the banner section, the store section, the feature product section, the options section. The items are going to be similar because we're not going to be creating a model and just the view model, so we won't be using any additional services to fetch the feature products or the option section. The items are going to be pretty similar here. We're not going to bother going into details here. Let's now create our view model. Then we'll create the main view and add it to the top bar just to have something to start with. This is going to be our view model. As I already mentioned before, we will just be retrieving the stores from a service. The other sections will be hard-coded. Now we can move on to creating each of our sections. We will begin by creating this banner up here. Here we have our banner cell. We'll just change the alignment here. And here we have our banner. Now let's create the section that will have these banners scrolling horizontally. Here we have our banners. Now, if you'll notice, the image is a little bit big. Let's try running this. We do have our scroll view, but the image is taking a lot of space. For that, we're going to be reducing the width of the image. Also because if we look at the App Store, you notice that the cell actually doesn't occupy the entire width of the screen. It leaves a little bit just for the next section. For that, we're going to include another parameter here, which is going to be the cell width. And that looks much better. Here you can see we have the other side and we have a natural padding. Let's run the preview just to prove that we can scroll. And now we have our banner section. Also, if we want to compare here with the preview, we're running in dark mode. So let's add that modifier. Now let's move on to here where we will be displaying our stores in rows, in 3 rows, scrolling horizontally. For this, we're going to be using a grid. Now we want the cell to be pushed to the left. It shouldn't be centered. Let's add a spacer at the end for this. And here we have our section for the stores. Here you'll see that I miss adding a link to the vstack, so the title of the store is appearing only it's centered with the grid. There we go. And this is how you use grid. When declaring the lazy H grid, which will be in horizontal, you just need to specify the amount of rows each of the columns in the grid is going to have. In this case, 3 with the same fixed width. You can also specify a flexible width or adaptive. And then you just declare the array. Then with this declared, it is all arranged for you. Let's move on to this part, which is the kit zone. Here we're going to have our featured products. Let's add this cell to our section. Here I don't need to be using a grid since I'll be having just a single item per column, so no need for a grid. And here we will also need to add a height. We could also be passing the cell height, but I'm not going to do this since the cell by itself, it doesn't matter what size of the screen, this is a good aspect ratio that we are seeing here in the images. If I play this, we will be able to scroll to our feature product section. Yeah, the padding is not enough, so let's add some spacing to our H stack. Better. Now let's go to our final section, which will be here the top categories. Here we will be adding options. Here with our option cell, nothing fancy about this. We just take the CSF symbol, put it here. I added the foreground color blue just so it can tell them apart from the title. Here we have added a divider to each of the options. With all of our sections, now we're ready to include them in our feed view. However, how can we tell right now what we have here? We will be able to do a VStack and then get the sections, but how will we know which of the sections to include? Because here we're getting first a banner section, then a store section, then feature options, but again, all of these are in feed sections. There is a protocol which all of these structs conform to, but how will the view know that the first section will be a banner feed section that takes this as a parameter? The next one will be a store feed section, which takes this other section as a parameter. We could do it with some switch statements, but there's a better way to handle polymorphism. It is called the visitor design pattern. And we're going to use it so that instead of having a huge switch statement or a huge if with casting, we can do it with a different entity that will help us keep things organized. In case you want to know more about the visitor design pattern, I recommend this page, Source Making. It's great for seeing all of the object-oriented design patterns. In this case, the visitor, which is a behavioral pattern. First of all, let's create our visitor protocol. Now, the only thing our FeedSection visitor is going to have is just one function per each of the structs that conforms to the FeedSection protocol. And what will it return? It depends. Since visitor is going to be generic, it depends on who is the visitor. Maybe it performs something like tracking or executing some web service or returning something, which in our case it's going to be a view, a SwiftUI view. but we're not going to constrain our protocol for this. We're going to be creating an associated type, and let's just call it result, actually outcome. Then we do exactly the same for each of the other views. And this would be our visitor. We'll have, instead of a switch statement, we'll have a function per each of the implementations, each of the classes that conform to the FeedSection protocol. Now in our FeedSection, we will have a new function, which is accept. So every FeedSection will accept a visitor. We need to constrain it here. So it will be a visitor of type V, and it returns the outcome of that V. And you'll notice we will have an error on each of these, and here comes the magic of the visitor. So for our banner section, in our accept, what we are going to do is return visitor.visit who? The banner section. And we just pass off. And that's pretty much it. Let's create our class that's going to implement that. It's going to be a FeedSection visitor. We'll immediately get errors. The first one would be the outcome, which was an associated type. You can declare it explicitly like he was proposing there, but we can also do it implicitly by declaring the first function. So let's try visiting the banner section. Our outcome is going to be any view. To import SwiftUI. Now we're going to be returning any view because we don't know which of the sections we're going to be returning. I cannot specify each one of these. And for now, let's just add one of these. And let's try visiting the other one, and you will see that now the autocomplete will give me the any view in the suggestion. That's because I already specified it here, so it takes implicitly the outcome. Now with our visitor, we can now implement the accept method in our feed view. Now if you saw, we had the cell width in some of the sections. So for that, we're going to need to know the dimensions of the view. For that, we need to use geometry reader. That is to be the first one to be declared here, and then everything is inside of the geometry reader. So we're going to ask the section to accept the visitor. And who's going to be the visitor? It's going to be the factory that we just created. And now, instead of adding empty views, any view, we're going to be creating our sections here. And you'll see that we will run into a problem here with the banner feed section. So the banner feed section is expecting a banner section, which we have. But then what about the cell width? How can we pass the width that we want, which we have it in our feed view with the geometry reader? We can enhance our visitor pattern to have another associated type. Again, no need to specify the type here. We're not going to be adding geometry proxy here. We're going to be adding another associated type so that when we can reuse this protocol for other scenarios. Now, when we accept, we also have to change it. Now here in our view, we'll be needing to pass in the data, which will be our geometry proxy. Now in our FeedSectionFactory, we need to specify the data here. And now we can pass the cell width here. And here we have our banner section. You see, it has 90% of the view, and then the other banner starts showing up. This is the same for the other sections. And here we have a layout similar to the App Store in iPhone. Thanks to how our implementation was made, I can even switch the order here effortlessly, and everything is rendered the same. Now, it seems that we are finished here, but what about iPad? By looking at our implementation, we can say that we still have ways to go. Although our app is laying out, it is not doing it quite right when the screen gets bigger. We see some screenshots from the App Store in iPad. You can see that the banner doesn't occupy that much width. Same goes here for what it is in our app, our store section. More items appear. For we have our feature products, we have more cells. And in our options section, the quick links that we have in our app, we have now two items per row. So let's change that. How can we tell the difference about the horizontal size classes? We shouldn't be using the size of the screen, but we could be doing it with just by seeing if the width is regular, we will be taking this layout. If not, then we will be using the one for iPad. For that, instead of using geometry reader, we're going to be using an environment variable. This variable will tell us if our width is compact or regular. Now, again, we pass our geometry to our visitor. We also need to pass our horizontal size class. Now we don't need to change anything in the visitor because we already specified the data. We just need to go to our factory and change the data. Instead of just having a geometry proxy, it's going to have a tuple where the first item is going to be the geometry proxy and the second one is going to be a size class. Here we could be specifying data.0, but I prefer us to do things better, so I will be naming the variables in the tuple. Now let's make the necessary changes for this. Here in our option section, we do need to make some changes since now we are going to have a grid. It did work, but we have to improve the alignment. Now let's try running it again on the iPad. Much better. Looks a lot more like the App Store. The size class to reduce the height of the sections. Better. Oh. Here have mistake. And there we have it. Let's try running in iPhone again just to check we haven't broken anything. Everything looks the same. There you have it. With lazy grids in the second release of SwiftUI that comes with iOS 14, it'll be much easier to implement complex layouts like this one that the App Store presents. If you are constrained with running iOS 13, I highly recommend you just embed a UI collection view in a UI view representable view. Honestly, it's not worth the effort laying out everything with H stack and V stack, separating it with rows by hand. Making adaptive designs like this one would be even much harder. So just stay with UI collection view until you can deprecate iOS 13. Hope you guys like this. That's everything for today. Bye.